Okay, with problem number 8, we're looking for the slope of the tangent line to the function g of x is equal to 6 minus x squared when x is equal to 1. And so we'll write what we're interested in, that g prime means the slope of the g function when the slope of the tangent to the g function when x is equal to 1. And our formula, as always, begins with limit as delta x approaches 0 of g of 1 plus delta x minus g of 1 over delta x. And at this point we'll actually plug in the 1 plus delta x into the g function, and we'll plug the 1 into the g function, and we'll find the difference of those two. And so we still have the limit as delta x approaches 0. Now our function is 6 minus x squared, and so we'll write that as 6 minus parentheses 1 plus delta x, quantity squared, then minus g of 1. And it might be easiest at this point to just consider the function g of x is 6 minus x squared. When x is 1, we're going to have 6 minus 1 squared, or 6 minus 5. So that might save you some simplifying if you just plug the 1 in at that point, and we'll get 6 minus 1 plus delta x, quantity squared, minus 5 all over delta x. And here we need to multiply out the 1 plus delta x, quantity squared. And we also have the 6 minus 5, so I can simplify that down to be 1. And I'll have 1 minus, and we'll put that whole expression in parentheses. Well, the fastest way to multiply one of these out is you're going to square the first term, that's 1. Then you're going to multiply the two terms together, 1 times delta x, and you're going to use the sign that's there, plus 1, plus. So we multiply the two together, 1 plus delta x, and then you're going to double that. And if you don't believe this is true, you can go ahead and FOIL that out and see what that looks like. But it's going to be 2 delta x. And then we always plus the last term, or the second term squared, so plus delta x squared, and all over delta x. Alright, so in simplifying now, we're going to need to apply that negative sign to everything inside of parentheses. And so we'll get 1 minus 1 minus 2 delta x and minus delta x squared all over delta x. We can see that the 1's will zero out there, as they should. If we do this correct, anything that doesn't have a delta x term in it should disappear. And so we end up with, I still need to write limit as delta x approaches 0. Now, we'll simplify one more time. We have the limit as delta x approaches 0 of negative 2 delta x minus delta x squared over delta x. We factor out a delta x. So we have limit as delta x approaches 0, then delta x times parentheses negative 2 minus delta x, and all over delta x again. The delta x's cancel, and we have the limit as delta x approaches 0 of negative 2 minus delta x. When we plug in delta x equals 0 now, we're simply going to end up with negative 2. And that is the slope of the tangent to the curve at that point. Now I'm going to bring in the graphing calculator to illustrate this. When we do this, we want to go into y equals. We're going to plug in our function here, 6 minus x squared. I'm going to go into zoom and standard. And what that does is gives me a picture of the graph of this function, 6 minus x squared. And what I'm looking for is the slope of the tangent line when x is equal to 1. And an easy way to do this is to go into Draw, and then option 5, Tangent. We're going to select the point we want to draw at, and that's 1. And it draws the tangent line to the curve at that point. So that's what we're looking for there. And if you notice, it gives you the equation of that tangent line, which is negative 2x plus 7, and the slope of that tangent line, which is what we're looking for, is negative 2. So hopefully that makes some sense there. And so I have a copy of that image there so you can see. We looked for the slope of the tangent to the curve when x was equal to 1.